Hi there. Today's lesson we are going to discuss about quotient rule. So quotient rule is if y equal to u over v, yeah, where u is function of x and v is function of x, then what will be the differentiation of y with respect to x? Yeah. So what we do, we write down the first function here v and then differentiate the first one, that is du over dx. Okay, so v denominator function, that is let's write down here, this is function first, then this is function second. So we write down second function differentiation of first, then minus sign, yeah, minus sign, and then it will be first function and differentiation of second function. Okay, so what we need to do, so u dv over dx, right, and here in the denominator then it comes v square. Is it okay? Now what will be the alternative way? Alternative way, we can write down dy over dx in an easy way. Let me write down v u dash and u v dash divided by v square. I think this is easy to remember. Okay, so in my lesson I'm going to apply this formula. If you're happy to apply this, you can apply this. Yeah, so dy by dx is v u dash minus u v dash over v square. Yeah, let's see question. Example 1. If question is like this, y equal to e to the power x over x, right? So how to solve this? So here this is our u and this is v. Okay, let's write down here, u is e to the power x and v is x here. Now we are finding u dash differentiation of u with respect to x, that is e to the power x. Okay, and differentiation of v with respect to x, v dash, it will be 1. So what will be dy by dx here? We are doing like this. So this is easy way. What you need to do, you just go this way first, ex, okay, and this way, right? So we are multiplying this. So first one is vu dash. So v is x, and u dash is e to the power x. Then put minus sign in between. Then u v dash, u is e to the power x times 1 divided by, it is v square here, so x is, so it will be x square. Yeah, so e to the power x is coming out, so what is left inside the bracket, x minus 1 over x square. Okay, so let's see another example now. So our next example is y equal to sin x over ln x. So here u is sin x, this is first function is u is sin x. So what will be u dash? So differentiation of sin x, d by dx of sin x is cos x. So we have I have written here cos x. Yeah, next we take v, so ln x is v, so let's write down here v is ln x. So v dash will be d over dx of ln x is 1 over x. So we have written 1 over x, right? Now what we need to do, our formula is vu dash minus uv dash over v square. So we are starting from here. So vu dash, this arrow we are following first. So dy over dx, vu dash, that is ln x dot cos x, dot is multiplication, then you need to put minus sign, and we are taking this one. Okay, sin x into v dash. Yeah, so sin x into v dash, so sin x times 1 over x. Now divided by, this whole thing is divided by v square, v is ln x, so it will be ln x whole square. Okay, now there is nothing in the denominator, so suppose there is a 1. If you multiply by x here, so it will be x ln x cos x minus sin x divided by This x is coming in the bottom, so it is x and ln x square, right? So this is your final answer. Let's go for another example. So in this example here it is y equal to sine x divided by 1 plus cos x here. So our u, this is u. So u is sine x. What about u dash? Differentiation of sine x is cos x. Now the next one is v. So our v is 1 plus cos x. This is v. So v dash, differentiation of 1 will be 0 and differentiation of cos x will be minus sin x, right? Now we need to write down dy over dx. So we need to start from here. Vu dash, so it will be 1 plus cos x times cos x, then minus sign. Then we need to multiply this one uv dash, so sin x and minus sin x, so it will be minus sin square x. This minus and minus will turn into positive, so that we will do it in the next line. Okay, and here is v, so v is 1 plus cos x whole square. So if we simplify, so it will be 1 cos x. If we multiply, let me rub this. Okay, if we multiply here cos x with 1, so it will be cos x with cos x, so it will be cos square x. This minus minus turn into positive, so it is sin square x over 1 plus cos x whole square. Now in trick we know this, cos square x plus sin square x is equal to, this is equal to 1. So in this place we can write down 1. So what is left in the numerator? 1 plus cos x. So here it is left 1 plus cos x, and here is 1 plus cos x whole square, right? Now 1 plus cos x and 1 plus cos x will be cancelled out. So what is left? So what is left here? 1 plus cos x cancel. So in the denominator we are left with 1 plus cos x. Yeah. So that is your final answer. Let's go for another question. As we know through differentiation, right, d over dx of sec x is sec x into tan x. Yeah, this is time sign, sec x into tan x. So how this is coming here? How this is coming? So here also we can apply quotient rule. So this is our next example. So how it is coming? So let's take y equal to sec x. And I'm going to show you how we are getting this formula. So sec x we can write down 1 over cos x. Okay, so this is our question. So this will be u and this will be v. So let's start. So if u is u is 1, then u dash will be 0, and if v is cos x, then v dash will be, differentiation of cos x is minus sin x, right? Now we need to start our journey from this side. Yeah, so vu dash, so dy over dx will be equal to, if you multiply 0 with cos x, then it will be 0, then minus sign, and 1 times minus sin x will be minus sin x, okay, and divided by cos x. So v is cos x, so it will be cos square x. So we got here sin x, this minus and minus will turn into positive, sin x over cos square x, and cos square x we can write down cos x times cos x. Okay, so good thing is here, if you see in GCSE, sin x over cos x, this is equal to tan x, right? So here I have written tan x, and what is left here? It is 1 over cos x. So 1 over cos x is sec x. So we get our formula, sec x into tan x. So d over dx of sec x is tan x into sec x. This is the way how beautifully we can apply quotient rule here, and we can get the formula. Similarly, you can get formula of d over dx of tan x You can put sin x, you can solve yourself d over dx of 10x. So you can write down d over dx of sin x over cos x. Yeah. So this will be u and this will be v, and you can solve by applying quotient rule, isn't it? Let's go for another example. So this is our question. If y equal to x divided by 3x plus 1, find dy by dx at 1 over 4. Yeah. So again, this will be u and this will be v. So let's write down u and v. So u is x, u dash will be 1. Now v, what is v here? V is 3x plus 1 and v dash will be 3. Okay, so let's write down dy over dx. So we start our journey from here, so we can multiply. It will be 3x plus 1 times 1, that is 3x plus 1, then minus sign, and x times 3 is 3x, okay, divided by v square. So it will be 3x plus 1 square. So once you open the bracket, 3x and 3x will be cancelled out, right? So if you open the bracket, then 3x and minus 3x will be cancelled out, and we are left with 1 over 3x plus 1 square. Now here new thing is you need to find dy by dx at this point. So there is a way to write, you can write down dy over dx at 1 and 1 over 4. It means x is 1 and y is 1 over 4. You need to put plug the values here. So 1 over 3, x is 1, so 3 times 1 plus 1 square. So 3 times 1 is 3 plus 1 4. 4 square is 16. So your answer is 1 over 16. So please remember, if you are writing dy over dx, write down like this. If you need to find dy over dx at the point, okay, so then you mention at this point. So this is the difference. Okay, let's go for another question. So find the stationary points of the curve. Curve is y equal to e to the power 2x plus 3 divided by x, and x is not equal to 0. Please pause the video and have a go. And this, you can assume this is u and this is v. Okay, and just try to find out, and I can help you for the stationary points. And you know, for stationary point, okay, what is the condition? Yeah, stationary point, what is the condition? Any idea? Yes, so for stationary point you just need to put dy by dx equal to 0. This is important thing, yeah, you should remember. So please pause the video and have a go. Welcome back if you have tried. So here u is e to the power 2x plus 3. What about u dash? U dash, here we can apply e to the power 2x plus 3 by substitution. So e to the power 2x plus 3 remains e to the power 2x plus 3, and differentiation of 2x plus 3 comes forward. Yeah, so it is 2e to the power 2x plus 3. Okay, what is v here? So v is x, v dash will be 1. So first we need to multiply this. So our dy by dx is multiplying, okay, this one. So you multiply this, so it will be 2x e to the power 2x plus 3, then minus sign, and then you multiply this, e to the power 2x plus 3, e to the power 2x plus 3 divided by x square, that is v square. So if you see, e to the power 2x plus 3 is common, so let's write down here e to the power 2x plus 3 is outside. What is left here? 2x minus 1 divided by x square, right? Now for stationary point, I'm writing in front, for stationary points dy by dx should be equal to 0. Okay, so if we put this thing equal to 0, okay, let me scroll this. So it will be like this, e to the power 2x plus 3 and 2x minus 1, whole thing will be equal to 0, because if you multiply, if you put it equal to 0, x square times 0 will be 0, and this thing will be 0. So here two things will be 0. First thing is 2x minus 1 equal to 0 and e to the power 2x plus 3 equal to 0. If you solve this, then it gives you maths error. Yeah, maths error. Okay, so here 2x will be 1 and x is 1 by 2. Okay, now we want a stationary point, so we need to find y as well. So what will be the value of y? So we know what is y. Y is e to the power 2x plus 3. So here we can put x to the power half. So in this expression, if we put x equal to half, then we can get the value of y. So let's put here. Okay, so sorry about that. So let's put half. So it will be y equal to e to the power 2 and then 2 and times 1 by 2, then plus 3 and divided by half. Okay, so this 2 and this 2 cancel, so we and this 2 is going in the denominator, so it will be 2 e to the power 4. So our stationary point is, stationary points are x is half and y is 2 e to the power 4. Okay, this will be your final answer. So in this question you need to find dy over dx. So let's do it quickly and you can pause the video and have a go. Yeah, so welcome back if you have tried. So here u is e to the power x over 3. If we find out u dash, then it will be 1 by 3 e to the power x by 3. Okay, now what about v? V is x and v dash is 1. Okay, so dy by dx we can write down, first you multiply this, so it will be 1 over 3 x e to the power x over 3 minus e to the power x over 3, you multiply this and divided by x square. Okay, so here we got e to the power x over 3 outside and x over 3 minus 1 divided by x square. If you simplify, then 3 is coming here and 3 is going in the denominator, so we can write down e to the power x by 3 and x minus 3, and this 3 is coming in the denominator, that is 3x square. This is our dy by dx. Okay, now if they say find dy by dx, now I'm inputting one more point, find dy by dx at points are given, suppose 3 and e by 3, then what will be the value? So as I told you, once you are finding dy by dx, always mention like this, dy by dx at points are 3 and e by 3. This is 3, e by 3. So what will be the value? Okay, so let's write down, wherever is x, you just put 3. So it will be e 3 over 3. So 3 over 3, let's write down here. Okay, so if we put 3 here, 3 over 3, that will be 1 e to the power 1 here. Okay, so 1 and 3 minus 3 becomes 0, and then here it is 3 and 3 square. Basically this whole thing will become 0. Okay, now we need to find equation of tangents. Okay, so I'm adding one more thing. If you need to find equation of tangent, so equation of tangent, this you need to find in this question. I'm adding one more part here. So equation of tangent is y minus y1, here dy by dx and x minus x1. And remember one thing, this dy by dx is always at points, right? x1 and y1. So we are not taking this value, we are taking this value dy by dx at the points. Okay, so here y minus y1, y1 is e over 3, so e over 3, dy by dx is 0 and x minus x1, x1 is 3. So if you multiply, this whole thing will be 0 and we got y equal to e over 3. This is equation of tangent, right? So remember, when you are applying equation of tangent, so do not take dy by dx, always take dy by dx at the points, okay, x1 and y1, right? So here is another question. This is exam question. Y equal to e to the power 2x and x minus 2 is square and x is not equal to 2. And you need to show dy by dx in this form where a, b and c are integers to be found. Yeah. So let's do this question. So this will be u and this will be v. So let's write down here. U is e to the power 2x, then u dash will be 2e to the power 2x, right? And v is x minus 2 square and v dash will be 2 x minus 2 and differentiation of x is 1, so that's right. Okay, so dy by dx if we need to write down, so we'll start from this side. Okay, so it will be dy over dx equal to this will be 2 x minus 2 square and e to the power 2x, then minus this one, so it will be 2 x minus 2 and e to the power 2x divided by x minus 2 to the power 4. Okay, so what we can do, we can take common here, so 2 x minus 2 e to the power 2x is outside. What is left here? X minus 2 and there is minus 1 divided by x minus 2 to the power 4. Yeah, so what we can do, we can cancel 1 x minus 2 here and 1 x minus 2 here, and let's see what is left over. So it is 2 e to the power 2x. Okay, so 2 e to the power 2x, and what is left here? Minus 2 and minus 1 becomes, sorry about the emails, x minus 3, and it is x minus 2 to the power 3. Okay, so this is our dy over dx. But if you compare this with the question was here dy by dx is a e to the power 2x bx minus c divided by x minus 2 to the power 3. So what will be our final answer when you are putting the value of a, b, c? So let me write down this. So if you write down a e to the power 2x and bx minus c over x minus 2 to the power 3. Okay, so a will be 2 here, b is 1 and c is 3 if you compare these two, so you will find these two. Now if you go for second question where they are asking find the equation of tangent at x equal to 1 but y is missing. Yeah, so we'll find y and equation of tangent both. Okay, so first find dy by dx at the point at x equal to 1. So if you put x equal to 1 here, so it will be 2e square and this will be minus 2 over minus 1 and it will be 4e square. So dy by dx is this. Yeah, and if you put x equal to 1 here in this equation, right? Okay, in this equation if you put x equal to 1, so what will be the value of y? So y will be e square and this will be 1 minus 2 minus 1 square, minus 1 square is positive, so y will be e square. So basically x is 1 and y is e square. Okay, so let's write down here equation of so y is e square, right, and x is 1. These are the point. Yeah, and we need to find equation of tangent. So equation of tangent is given by y minus y1 dy by dx at the point. So I'm writing here x1 and y1 just for to remember, because lots of student does mistake, they just write dy by dx, but make sure you need to find dy by dx at x1 y1 and it is x minus x1. So y minus y1, y1 is e square, dy by dx at x1 y1 is 4e square. So let's write down here 4e square x minus x1 is 1, so this will be 4e square x minus 4e square, and this is minus e square this side, and y. So our equation of tangent is y equal to 4e square x and minus 3 square. Okay, this is equation of tangent. I tried to cover maximum questions based on exercise 9e of A level differentiation. So hope it is going to help you. And if you haven't subscribed my channel, please subscribe so that you will be the first one to get notification from us. So thank you and thanks for watching. Goodbye.